Hi guys, good evening. So today we'll be starting with the FTD. So before starting, let me ask is there anyone who is attending for the first time today? Like most of the students I can see are from the ASA batch, right? That we have completed. Amisha, this is your first security module, or what are the modules you have completed?
Hello,
Yes,
am
hi.
I audible?
Yes, you're audible.
I completed ASA WS.
Okay, so ASA you have completed, right?
Yes.
Okay, guys, what about everyone else? They are attending ASA with me only. Okay, then that's great, because usually what we do is like how our session flow goes is generally the first session we keep it for introduction to your CCI. What is the current version?
6.
Is it? Is it version 6? Six was the older version. Last year it changed, right? Correct. So with your CCI security version 6. Okay. So this is generally our first session. Then second session, we go with the fundamentals of firewall. Then this is the day 3 actually. Day 2 we see about evolution of firewall. That how your firewalls evolve. Then day 4 onwards, we go with the lab setup. Okay. And further we start doing the topics. So these are the first 4 days. Okay. So let me know if all of you are aware or not about the CCI security version 6.1, like what all the changes and everything is there. Everybody is aware? Yes or no? Okay, Bashir says yes. What about other people? Please be responsive, please. Okay. Deepak says yes. Out of 8, only 2 responses. What about other people? The question is, are you guys aware about CCI security version 6.1? What all the changes have been done? Yes. Okay. Tausif says no. Okay. Tausif, you were attending ASA, right?
Yes, sir.
Then how come you don't know? This is the first session for ASA that we have discussed. Okay. What about the evolution of firewall? How your firewalls evolved? Everybody knows? Yes, yes. That's good. Okay, Tosif says yes. Okay, so tell me one thing. Before having the firewalls, what we were using? Before the firewalls, what we were using? Routers? Host? Routers were there, right? Yes. Okay. So, if we talk about the time around 1990s, that time what we were using? We were using routers with ACLs. So what was the problem when we were using routers with ACLs? What problems did we face? What was the problems that we were facing? Why we had to come up with a firewall? Okay, let's do one thing. We'll brush up this thing evolution. CCI security track, I will not discuss as all of you have already completed some of the modules of CCI security and you guys might be aware. Okay, one thing I'll point out from this thing that from the CCI security version 6.1, what is the one thing that I want to point out here? That according to FTD, what we are going to use. Okay. So let me just bring it up. Okay. CCNP, CCI, this certification track you have already seen. Here we have to notice one thing. What is it? That see under the firepower family, okay, under the firepower family we have certain devices. What are the devices that are coming under the firepower family? These three are the devices. These three devices, they are falling under the firepower family. Okay, so there has been a version change here. Okay, so in which case there is a version change. Your FTD, it was 6.2. Okay, and still your FTD 6.2 is there. But your NGIPS version 6.2 was there. Now the NGIPS version is 7.0. Okay, and FMC version 6.2 was there in the version 6.0. Now in the version 6.1, it is version 7.1. Okay, so as of now, FTD no change. So we'll go with the version 6.2. This is the thing that you need to take care of. Okay, so we'll be using FTD, and for management of FTD, we are using what? For the management purpose, we use FMC. This is your FMC. Okay, but in the newer version, if you see, they are mentioning that FMC is what? 7.1. But it is not like this. Okay, how it is? That if you are using FTD 6.2, so FTD 6.2 will be managed with the help of FMC 6.2 only. So here we will be using the FMC also 6.2, FTD also 6.2. Because if you go with the 7.1 version, so 7.1 version is not compatible with your 6.2. Okay, with the help of 7.1 version of your FMC, you cannot manage FTD 6.2. That is not possible. The minimum requirement for your FMC 7.1 is right here. The minimum requirement for this thing is FTD version 6.5. At least version 6.5 should be there. So it cannot manage your 6.2. Okay, so what we will be using in our lab is FTD also 6.2, FMC also 6.2 only. This thing is clear. Okay, this is one thing that you need to take care, that FTD version is 6.2, FMC version is also 6.2. Okay, now let's go for the brush up. Other than that, all of you are already aware about, what all the things we are going to discuss here and all. So let me just remove it. So around the year 1990s, what was happening? We were using routers. Okay. So you were having what? Router. And then you are connected to the internet. And on the internet, you have some servers, PCs and all. Then you have your internal network. And then you have your internal PCs. Okay, and consider you have a server also. And this is kind of scenario we have. Okay. So this is your server. And here you are running HTTP service. And this is your PC1. And this is your PC2. And this is your switch. Then you have your router. You have your internet. Consider this as google.com running the HTTP service here. This is, let's say, your Delhi branch. Okay. This is your Delhi branch. So this is a kind of scenario. Now what? If you consider, let's say, on the inside, this is your inside network. That is your LAN network. Okay. So this is your inside, and this side we have your outside. Consider on the inside, you're using the network, that is 10.110/24. And here on the other side, you are using 11.110/24. Okay. This interface here, Z 0/0. This interface here, Z 0/1. Okay, consider IP here, let's say 10.1.1. Here we have 10.1.1.2. Server has 10.1.100. Here we have 10. On this side we have 11.1.10. Okay. Here we can consider 31.1.1. And this is Delhi branch, let's say 21.1.1. Okay. So consider your PC1 wants to access Google. So how the traffic flow will be? What will be the packet flow? Your PC1 will generate a masses. Okay, in the masses, your PC1 will say that source IP, destination IP, source port, destination. What will be the source IP here?
10.1.1.2
PC1 is generating the masses.
or 10.1.1.1
Okay. 1 destination IP.
13.1.1
31. Then source port,
one random number
any random from which range?
1024 to 65,535.
Correct. Okay. So as of now, let's consider it's random. And destination port,
80.
destination port will be 80. Now, this traffic will go from PC1 to the router. Router will check what? What a router will check?
On destination IP and source IP.
Is it going to check source IP? Really? router will just forward the packet based on the destination IP address. Okay. So router will forward it. Packet will be forwarded to the internet. Internet will also see the destination 3111. Packet will be forwarded where? To the Google. Now what Google will do? Respond. So let's generate the response message. Source IP, destination IP, source port, destination port. What will be the source IP?
13111
3111. Destination IP?
or 10111.
10111. Then
80
source port is 80. Destination port
random number.
will be random. Okay. Now here, your Google will send the packet to internet. Now what internet will do? What the internet is going to do? Your ISP, what they're going to do now?
Check the destination IP
Okay, check the destination IP 10111, then
and check the destination port number.
okay, then what after that?
It will forward the packet to the corresponding destination IP.
Okay, so you mean to say it will forward the packet to the router, right?
Yeah.
But 10111 is a private IP.
It will not be there, so
Private
it will drop the packet.
Exactly. Okay. ISP will drop the packet. But as of now, let's consider just we are seeing a scenario, okay, that already NAT and everything is done. Okay. So according to that, let's consider internet will forward the packet to the router. Router will check what is the destination, 10111, and then it will forward the reply here. But normally this packet will be dropped. Why? Because this is a public private IP. Okay. This is clear. But as of now, we are not considering NAT and private IP thing right now. We are considering NAT is also done, and this is just a public IP translated IP. Okay. So this will come to the router, and router will forward the packet here. This thing is clear? Yes or no? Okay. Now, let's consider another scenario. This is one scenario when I was going from inside to outside. This was one scenario when I was going from inside to outside, and then my reply was coming from outside to inside. This is fine. Now, another scenario, let's consider that this Delhi branch wants to access your server. Okay. So if the Delhi branch wants to access your server, Delhi branch will generate a packet based on the information like source IP, destination IP, source port, and destination. What will be the source IP?
(2111)
2111. Destination IP?
100.11100. Sorry, 10. Yes.
Okay. Source port?
Is that random?
Definitely it will be random.
Yeah.
What will be the destination port?
80.
8. Okay. Now, this message will be sent to the internet. Internet will check the destination IP, will forward it to the router. Now, what your router is going to do?
Check the destination IP and
Will
forward.
check the destination IP, that is 1011100, and will forward it here. Correct?
Yes, sir.
Then this server will respond and the reply will go here. Okay. Now let's consider in here on the internet only, hackers are also there. On the internet itself, we have hackers. And let's say this guy is having an IP something like 40.1.1. So same like Delhi branch, your hacker can also generate a message. Source IP, destination IP, source port, destination port. In this case, source IP will be, what will be the source IP here?
4111.
4111. Destination IP,
Or 101100.
correct. Source port,
Random.
random. Destination port,
80.
now. This message will go to the internet. Internet will check the destination, will forward it to the router. Router will also check the destination IP, will forward it here. So can I say your hacker has an access to your server?
Yes.
Now let's say you don't want the hacker to access your servers. What are you going to do? You have to filter the traffic.
Yes, sir.
And what you will do? You will go and say,
Create a ACL on the router.
correct. And in the ACL, what we'll do is we will deny the hacker's IP address. Okay. So what we'll do here, we'll say if source equals to 4111, action should be what? Deny. Right? This kind of ACL you will create, and then you will implement this ACL here. In which direction? Inbound or outbound?
Inbound.
So this will be in the inbound direction. Correct? Now, once you have defined the ACL in the inbound direction that, okay, if the source is 4111, action should be denied. Or we can allow only the Delhi branch inbound. See, if you will allow only the Delhi branch inbound, in that case, what will happen? Remember the implicit deny statement? That will deny everything else. Okay. So now what? When the hacker will try to access, message will come to the router. Router will match the ACL. Is the source 4111? Yes. So what should be the action? The action
Deny.
should be deny. The action should be deny. So now this traffic is dropped. So that means hacker is not able to access. We are secured. But what if the hacker will try to manipulate this IP address? What if the hacker will say that, okay, this time the IP address is like 4112. And now if the hacker will generate the message, we'll go to the router. Router will check. Is the source 4111? No. That means this action has not to be taken and hacker will get the access. Right? This is one possibility. Another possibility is what? That might be the hacker will not change its IP address, but somehow the hacker was able to compromise one of the system in the Delhi branch. Okay. Might be the hacker was able to compromise one of the system in the Delhi branch. And once the hacker was able to compromise one of the system from the Delhi branch, now what the hacker can do, hacker can generate a traffic from the Delhi branch itself. Because one of the system in the Delhi branch is under the control of hacker, right? So when a message will be generated from the Delhi branch, this will be the criteria. This will be the scenario. And here, the hacker will do what? Hacker will attach something called as payload. And in the payload, let's say the hacker will attach a Intrusion. Now what? Now here you can consider that case also. Let's say even if you allow only Delhi branch IP, even if you allow only Delhi branch IP also, that condition also you can understand here. That here the traffic will be generated from the Delhi branch. Hacker has generated this traffic. This traffic will go to the router. Router will check, okay, who is it? 2111. So not matching the ACL, traffic is allowed. Payload will get executed on the server. And what will happen? Eventually, your hacker will also get compromised. This is clear. Or might be the hacker itself, they will spoof the IP address and they will use the IP address 2111. And then they will generate the traffic. So when we are using a router, there is a problem. What is the problem? The default behavior. What is the default behavior of a router?
Hello.
Hello. Exactly. Okay. So here the problem we are facing is what? The default behavior. What is the default behavior of a router? Is allow. So that means router has a route, router will allow it. That's it. Then what happened? Cisco came up with a solution. What was the solution? So around the 1990s, we were using routers. Then in the year 1994, Cisco came up with a solution. Okay. Cisco came up with a solution. What was the solution? The solution was Cisco fixed firewall. Cisco came up with a firewall concept. Okay. Now this fixed firewall was a firewall which was having your router capabilities plus firewall capabilities. Okay. But one thing this was missing. Your PIX was missing one thing, which is VPN. Okay. Your PIX firewall did not have VPN capabilities. Okay. And for this reason, if we are using PIX, in that case, we have to use one more thing. What is it? You have to use VPN 3000 concentrator. This was another device. We again had to use VPN 3000. How did this device look? So look at it. Cisco PIX. Okay, so you will be able to see it. This was how your PIX firewall looked like. You can see Cisco PIX. Okay, but this was not having what? VPN capabilities. And because this was not having VPN capacity, we were using Cisco VPN 3000. This was another device that we were using. Okay, you can see here. Cisco VPN 3000 concentrator. Okay, so this was being used. Now what? If you want to use a firewall in your network, so in place of router, you were using PIX, and along with the PIX, you had to go and use what? VPN 3000 also. Two devices you have to purchase. Okay. So initially this thing worked, okay, like PIX was working fine for some time. Then, but again, you know, companies had to go with two devices. That is VPN 3000 they had to purchase because they wanted security. Okay. They wanted secure communication over the insecure network. So they had to go with the VPN also, and they had to purchase PIX also for security. Then later on, around this year 2005, what Cisco did? Cisco combined your PIX and VPN. And Cisco brought up its new firewall series, which was Cisco ASA, Cisco Adaptive Security Appliance. Okay. Now what? ASA was having the features of router, firewall, plus VPN. These all features combined. Okay. And once in the year 2005, your Cisco brought up your ASA. In the year 2008, in the year 2008, PIX was announced, end of life. Okay. In the year 2008, PIX was announced, end of life. Why? Because Cisco wanted to have business, right? Because if people who are already using PIX and VPN 3000, why would they go with the ASA? If it is the same thing, right? So in the 2008, they announced that okay, PIX is now end of life. So companies, they have to switch to ASA. Okay. But ASA what? ASA is a stateful firewall. We'll come to it tomorrow. Okay, that what is stateful and stateless and all. ASA is a stateful firewall. But ASA is not a next generation firewall. ASA is not a next generation firewall. That means simply what? That your ASA is capable of filtering the traffic based on layer 3 and layer 4 information. Your ASA firewall can filter the traffic based on layer 3 characteristics and layer 4 characteristics only. This is clear. Now again, if you're using ASA, you're getting what? Only layer 3 and layer 4 filtering. But we have a benefit of using a firewall. What's the benefit? That here, in this case, your default behavior of a firewall is what? Deny. The default behavior of a firewall is what? Deny. That means if you are using this kind of network, if you are using this kind of setup, but here in place of router, what you're using is ASA. This is your ASA firewall. And in case of ASA firewall, the default behavior is not deny, but it is allow. Sorry, not allow, but it is deny. Okay. Now in this case, what will happen? That if anybody will try to come from outside to inside, anybody, whether they are authorized, whether they are your branch also, if anybody is trying to come from outside to inside, according to the default behavior, what will happen? The traffic will be denied. The traffic will be dropped. Okay. So this is the benefit of having a firewall, that according to default behavior, the traffic will be denied. Okay. So now if you are going from inside to outside, in a firewall, what happens? Inside to outside, everything is permitted. In a firewall, inside to outside, everything is permitted. But from outside to inside, nothing is permitted. Okay. So nobody will be able to access from outside to inside. But the thing is, what if the hacker was able to compromise one of the system in the Delhi branch? And then from there, the hacker is generating the traffic. Now, according to default behavior, firewall will deny the traffic, but you want that, okay, your Delhi branch should be able to access your server. So what do you say? You will use the ACL here to permit the traffic. In case of router, we create ACLs to deny the traffic. In case of firewall, we create the ACLs to permit the traffic, right? So you will say that if source is, let's say for example, 2111, the action should be what? Hello, or permit. And now what will happen? When the hacker will generate a malicious payload from here, or one of the employee in the Delhi branch is having some malicious intention, they will generate a malicious traffic. Okay. So what is going to happen? When this traffic will come into the ASA will check the ACL. Because by default, everything is denied. According to default behavior, it will deny. But ACLs will override the default behavior. So what will happen? The action will be taken as allowed, and the traffic will be allowed. Why the traffic was allowed? Because ASA just checked the IP address. ASA did not check the data. The layer 7 ASA did not check. ASA is not capable of filtering based on layer 7 information. That is the problem. Okay. So that means in ASA, you do not have a L7 filtering. No L7 filtering. In case of ASA, there is no L7 filtering. Now what? Again, Cisco had to come up with a solution because there is no L7 filtering. So what Cisco did to come up from this kind of situation? In the year 2013, okay, in 2013, Cisco acquired Sourcefire. Cisco acquired a company, Sourcefire. Now, Sourcefire, it was very famous for its IDS solution. Okay, they were having an IDS and IPS solution for which they were famous. And in the Sourcefire, they were having something known as Sourcefire 3D system. In Sourcefire, they were having what? Sourcefire 3D system. Now, what is this 3D? 3D is not 3 dimensions. 3D means 3 devices. Okay. So Sourcefire was having their own firewall. Okay. So first of all, they were having, what are the 3 devices? Sourcefire IPS. They were having Sourcefire next generation firewall. Okay. This was IPS. And they were having something known as Sourcefire Defense Center. Okay, like this, 3 devices were there. So this defense center was nothing but their manager to manage these 2 devices. This Sourcefire NGFW, this was the firewall, and Sourcefire IPS, this was the intrusion prevention system. Okay, so I believe all of you are aware what is an intrusion prevention system and what is an intrusion detection system. That means you are aware about IDS and IPS, right? Everybody is aware? Yes or no? Guys, IDS, IPS aware or not? Please brief it once. Okay. What about the people? Nobody is aware? Okay, no problem. This thing, although I have explained when we were discussing ASA also. See, IDS. Intrusion detection system. And IPS, intrusion prevention system. Okay, these are the two technologies. What is IDS? IDS is capable of identifying malicious traffic. Okay, both of these things, they can check your L7 traffic. They can monitor your L7 traffic. But with IDS, what is the thing? That your IDS is only capable of detecting. Okay, your IDS can detect an intrusion attempt and generate alert. This is what your IDS can do. Your IDS cannot prevent an intrusion. That means with the help of IDS, you can just generate an alert. You cannot take an action. Okay, action is not possible with the help of IDS. But with the help of IPS, you are capable of taking an action also. So your IPS can detect an intrusion attempt as well as and can prevent it by blocking malicious traffic. Okay, by blocking malicious traffic. So this is what your IPS can do. Now everybody is aware what is an IDS and IPS. As the name suggests, one will detect, another one will prevent. Okay, and IPS has the capabilities of both your IDS also, IPS also. So nowadays we have a common term, that is IDPS, intrusion detection and prevention system. Okay, and in most of the times you will see IPS only, and in rare cases you will see IDS also. So you must be aware about all these three things. Okay, one is IDS, IPS, and then we have IDPS. That is intrusion detection system, intrusion prevention system, and then IDPS is a common term, intrusion detection and prevention system. Okay. Now, so what Cisco did? Cisco acquired Sourcefire, and then they brought up a new series of devices, and they have this Firepower family now. Now, directly it was not Firepower. Before that, we were having Firesight, okay, Firesight system. But that part we'll discuss it tomorrow. Okay. Today, let's just directly talk about Firepower. Okay, so Cisco named its, the new device product family as Firepower. Okay, so according to Firepower, right now, what are the devices we are having? We are having Firepower NGIPS. Then we have Firepower Threat Defense, which is your FPD. And we have Firepower Management Center. Okay, this is the new product family from Cisco. After acquiring Sourcefire, they changed the Sourcefire names to Firepower. Okay, so in 2013, your Cisco acquired it, and now they said that okay, if you are using an ASA and if you want layer 7 filtering, now you can purchase one more device from us, and that one device is what? Your NGIPS. Okay, this is the device that you can purchase. So what will happen? Your ASA will do what? L3, L4 based filtering, and your NGIPS will do what? NGIPS will do L7 filtering. Okay, so that means after acquiring Sourcefire, if the organizations, if the companies, they wanted layer 7 filtering, how their network was, The network was something like you have an ASA and then you have to use NGIPS also. One more device you have to go with, that is NGIPS. Okay, so this ASA will do what? Based on L3 and L4 filtering. And this NGIPS will do what? NGIPS will do L7 filtering. This is clear? Okay. Then again, two devices were there. Companies had to go with two devices. So later on, just after 1 year, Cisco launched new product, which is your FTD. Okay, first of all, they started selling IPS. Then after, they launched what? Their FTD, that is Firepower Threat Defense. So FTD is what? If we talk about your FTD, so FTD, you can consider it a combination of your ASA plus NGIPS. You can consider it like this, but also there are many more features attached. Okay, like you can perform. There are sandboxing features available. Okay, we do have URL filtering features. We do have micro application filtering. Okay, then we have SSL decryption policies. So multiple different kinds of policies are there in here. Okay, multiple different kinds of concepts have been mixed here, like data loss prevention concepts are there. So ASA plus NGIPS overall you can consider, but there are many more features due to which your FTD is also known as next generation firewall. Okay, your FTD is also known as what? Next generation firewall. This is Cisco's next generation firewall. So in FTD, what will happen? That in FTD you have two engines. Okay. So here, according to this ASA plus NGIPS, we can understand like, okay, this will do what? L3, L4 based filtering. And then your NGIPS will do what? L7 filtering. Okay. So like I said, in FTD, there will be two engines. What are the two engines? Number one, Lena engine, and number two, Snort engine. These are the two engines we have. Okay, so your Lena engine is like ASA. This Lena engine is responsible for L3 and L4 filtering. Okay, while your Snort engine is responsible for L7 filtering. Is it clear? Okay, so now once we are using your FTD or you are using ASA with NGIPS. So in that case, if somebody is trying to go with a malicious payload, malicious data, so ASA might allow it. ASA might allow this, but NGIPS will do what? Block this traffic. So this traffic will never reach the server. This is clear. Okay, so this is a very brief I have given you for this entire journey, that how from your routers we have come up to the next generation firewalls. Okay, so this was the evolution part. Tomorrow what we'll discuss is about your fundamentals of firewall. Okay, so there's a task for you people. What is the task? That you have to check about types of firewall. Okay, you have to check about types of firewall. Today on the day one itself, I'm not covering a lot. Why? Because tomorrow might be more students join. Okay, so accordingly we will start. And here we will be skipping some of the part. What is the part? Like I was talking about CCI introduction and all that part we will skip, and directly tomorrow onwards we will start technical. Okay, because you guys have already attended some of the security modules, so no need to give you that introduction. So this is clear, right? to everyone? The evolution part? All right.
Yes.
So this is what you have to research today. That is types of firewall. Okay. One is types of firewall and one you have to check. Yes, that is enough. That would be good. Remaining things I'll discuss. Okay, so now let me do one thing. I'll share the form link with you people. So you guys submit the form so that I can give you with the drive access. It's form link I have to share. Okay, so while submitting, how many days are required for FTD? It will take us around 5 weeks. Okay. And FTD will be kind of a bit slower only. Like, in FTD, we have to create the policies and we have to deploy it. So the deployment part is something where you have to wait. Okay. That is the thing. So it will take us around 5 weeks, but we'll go accordingly, slowly, no problem. Okay. Almost every day, one topic we will cover. And also let me show you what are the things we are going to cover in the FTD, like what are the labs we are going to do. Some of the labs I'm showing you and remaining things we will discuss. 32 GB memory is enough to do lab in home PC. See, we will be using FTD, we will be using FMC. 2 devices are there. 8 GB each device will take. Then we will be using Active Directory, 8 GB that is going to take. Okay, so you can say like your 32 GB will be a very neck to neck. Okay, because see, it's not about RAM, it's more about CPUs. How many virtual CPUs you have. Okay, because they will try to exhaust your CPUs. Yeah. So first of all, we'll see about your FTD. Okay, so how you configure the management IP in the FTD, then how you configure management IP in the FMC. Okay, for the GUI access, then how time synchronization, users and roles, how you integrate your FTD with the FMC. So here right now, FDM is not mentioned. Okay, so we will discuss before going with the FMC. I will show you about the FDM also. So like some of the labs are not mentioned, which I will be covering. Okay. Then how you can configure the inside outside DMZ interfaces, then how you can configure the routing part. Okay, static routing, dynamic routing. Then we'll talk about how you can give a default route. Okay, then redistribution, this right now we are not using. Okay, so then we will go with the access control policy, that how you can create policies and how you can allow the traffic. See, in ASA, you might have seen the security level concept, but here in the FTD, there is no security level concept. Okay, that is there only on the ASA. Then here we have only NAT and PAT, but again, we will see what all the types of NAT we saw in the ASA, same types of NAT we will see in the FTD also. So if you will see here, some of the things will be similar only, like NAT is there, HA is there, high availability. Okay, so these kind of things will be same. What will be extra? Like application visibility control, SSL policy. Okay, then site-to-site VPN configuration will be there. Then URL filtering policy will be there. Pre-filter policy will be there. Okay, so few things will be extra. L3, L4 based, that will be kind of similar. And one more thing, that in ASA, we were working completely on the CLI only. Okay, we were using Camins. Here, 99% we will be using graphical. Okay, so here we will have the graphical based concept. This is clear. So these are some of the labs, but these are not all of them. There will be more labs that we will be doing. Okay, there will be more labs that we will be doing. And this is the lab document which I'll be sharing with you guys. So what you can do is you can refer to this and every single lab you can easily complete. Everything is very well mentioned here, so you can easily complete it. Is that clear? Okay, so the form link I have already shared with you guys. So when you submit the form, make sure your details are correct. Okay, especially your email address will be required. Otherwise, you will face problem in getting the drive access. Okay, so make sure your emails are correct. Anything you guys have to ask? Can you send the link again? Okay. Here's the link again in the chat. So tomorrow, come prepared with the types of firewall. Okay, that is the part we will discuss. Then after we'll discuss about firepower family. Okay, and then maybe day after tomorrow, we'll go with the lab setup. So this week we'll do the lab setup. Okay, lab setup itself will take, it will take 2 sessions at least. Okay, because depending on how we want to see that, like whether you guys want to see it in the ESXi or EVNG. Okay, so both are having, like EVNG lab setup will not take very long time, but ESXi lab setup, this will take time. Okay, so this week we will do the EVNG lab setup, and next week onwards we'll go with the ESXi. Clear? All right. Okay, then hopefully all of you have submitted the form. Okay, guys, then I'll see you tomorrow. Have a good night. All right, guys. Good night. Bye-bye.